All right, so up on the board you can see you're supposed to be getting your notes out. We're going to use your notes to find all these formulas and all these definitions and all the things that you might want to put on your note card. You also have a notebook quiz next week, so real quick, as you're getting your notes out, check for these sections. All of these sections are on your notebook quiz. This is the last time we are meeting in class before your notebook quiz. So make a note of the sections you're missing, and between now and Monday, you need to make sure that you find those notes. They're all on the YouTube channel. I can email you the links if you let me know which ones you need. All right, so flip through your notes. This is the first thing we did. We're going right through the notes in order. Does anyone have any information that they think might be helpful to know for convex versus concave polygons? So you could write the definition. I don't know if that would be super helpful. Can anyone read the definition and actually know what it means?
Say the meaning of it in your own words.
Okay, yeah, so if you want to write the meaning in your own words, you can. I'll give you a minute to do that. If this was me, honestly, I would probably just draw an example of each. So like convex, remember it's where if you extend the lines, none of them go inside the figure. So maybe something like that next to convex. And then maybe like concave over here, we draw something like, and then maybe like a quick note, like going inside the figure or something like that. Now, again, I'm not grading your note cards. I don't care what you put on your note cards. I'm just trying to help you understand maybe what is useful and isn't useful when making a note card. If you want to put the definition, that's fine. If you just want to put this, that's fine too. Whatever you feel is useful, but I will give you some time to put whatever you would like on your note card. Does anyone have anything in their notes for equilateral, equiangular, and regular that they think might be useful to know for the test? Or is this something you already have and you're not really concerned about memorizing it because you already know it? Or what do you think? Equiangular.
Equilateral means the sides are even, and regular means both are equal.
I'm finna break this pencil.
All the angles the same?
Irregular, isn't it like all of them are the same?
The same angle.
Okay, so equiangular is all the angles are the same. What's equilateral?
All the sides are the same. Oh, the boy, come on.
Good.
And regular is where angles and sides are the same.
Very good. And regular is when all angles and all sides are the same. All right, I'll give you a minute to get that down. If you feel like pictures would also be helpful, go for it. If you feel like this is enough, go for it. If you don't want to put any of this, that's fine too. Remember, the entire chapter is going on that itty-bitty note card, so only write what you absolutely need to write. All right, here is a really, really good one. The sum of the interior angles of a polygon. There is a very specific formula. Can anyone find it? I believe now we're into 8.2. Anyone have it? Has an N in it.
Isn't it parentheses n minus 2?
Yes, I would definitely put this in your notes. Or I mean on your note card. Remember, this note card, you can definitely, I would highly recommend bringing it to the test next week. You can also use it on your final, so keep it safe. Keep it handy. Do not lose it. So again, on your note card, I would indicate what we're talking about. Some of the exterior angles of a polygon. Now this one's a little different. Does anyone remember what the sum of the exterior angles is?
360.
It's always 360. So if that's something you already know, maybe don't waste space on the note card for it. It also might be something if you can shorten that up. That's kind of a lot to write sum of exterior angles of polygon. If you can somehow shorten that and still know what it means, I would recommend that. But the sum of the exterior angles is always 360.
How do you get there?
So I just by memory, I think this was 8.3. I might be a section or two off. But does anyone remember how to find the area of a square or the area of a rectangle? Area is always A equals base times height is a rectangle. Good. So somehow let yourself know that that's the rectangle one. And the square one is what? It's basically the same as base times height, but remember that the sides were all the same, so it's just s squared. Yep. So yeah, again, here's a little side note. If you don't know what these letters mean, it's pretty useless, and it'll be even more useless next week when you look at it. So draw little notes off to the side, actually telling you what each of these things mean. Area of a triangle. That is, don't quote me, but I think that's 8.4. Maybe 8.5. I think 8.4. Area of a triangle. Anyone have it? This is where it starts to get a little more challenging. 1/2. And then it's just like a rectangle. Base and height. So now you're doing 1/2 the base times height. This is where typing into the calculator will seem to be the biggest problem for people. So if you also want to make some little note about how you type it in, again, we can practice a little bit next week when we're going through the review. And if something isn't quite making sense on your note card, you can add notes then. But that is the formula for area of a triangle. Anyone remember how to find the area of a parallelogram?
Isn't it area equals base?
Base times height is something else with parentheses?
Nope, that's it. Actually, area equals base times height, so it's the exact same as a rectangle. So if you don't even want to use up the space, maybe you could put it right next to the rectangle one and just kind of draw an arrow. Also works for parallelogram. Again, these are your note cards. Whatever makes sense to you, that's what you should write down. I can't really tell you how your brain works. I can just give you suggestions about what I would put.
Area equals.
This is the harder one. This is
8.6. Area equals 1/2.
This is the 1/2
Height.
times the h, and then this is the one that requires the parentheses.
B1
B1,
plus B2.
B2. This might be a really helpful one to write down what all these things stand for if you don't already know. Like these two are both the bases. This one is the height. It might also be helpful to draw a little example. Again, I don't know what you're going to struggle with, but if you maybe just want to draw something like that, just, again, you know where you struggled during these sections, what you had to keep looking back in your notes for, what you had to keep asking questions for. So those are the sort of things you want on these note cards. So now we're getting into circles. This is what we did yesterday. This should be real fresh.
It's 8.7.
There were two formulas for circumference.
C equals pi times B.
Okay, so one of them is pi times d. What's the d stand for? Diameter. And remember, the diameter goes all the way across. So you might want to draw a little picture, like when it looks like this, you use this formula. What's the other one for circumference?
C equals 2
2 pi r. And you use this one when you're given the radius. So again, if you're struggling with when to use each formula, it might be helpful to write down what they would look like for each of them. So again, if you're given the diameter all the way across, you use this one. If you're given the radius, you use this one. They're really interchangeable just because we know that the diameter is twice as long as the radius, so the 2r and the d are the same value. But again, whatever you need is what you should write down. So this is actually the last topic that I'm going to suggest that you put on your note card. And then you can just use the rest of the space for whatever you think is helpful. You might want to just leave some space for some examples next week once we do our review. Again, just whatever you think will help you. These are your study tools, your test assistants for next week. Area of a circle.
A equals
Pi r squared. Very good. Some people struggled with typing this into the calculator, so if you remember how you typed it in yesterday, you might not remember that next week. So if you want to make a little note to yourself, like hit the pi button, then type in the radius, then square it. What if you're given the diameter? Because there is no diameter formula. So if given diameter, what should you maybe...
multiply by 3.0.
If you're given the diameter, how do you find the radius?
Divide by 2.
Yeah, so if you're given diameter, divide by 2 to find radius. That might be helpful if that's something you're struggling with, or you could, make a little diagram instead, like if given something like this, divide by 2. Again, whatever you think will work for you, however much space you have, however big you write, that'll kind of determine what you need to write down. So those are my suggestions. Again, your notebook quiz is going to be the next thing that happens in this class, so you can spend the rest of the hour working on your notes. You can spend the rest of the hour perfecting this note card exactly how you want it. You spend the rest of the hour working on old homework. You can spend the rest of the hour studying for that test that's going to be next week as well. But again, those are my suggestions for your note card, and then the final note card product is up to you. Any questions?